Assalamualaikum, I am Anisa Sofea Binti Naim Shauqy with matrix number 2023104453, and I'm going to present task 1 and task 2. Okay. For task 1, which involving a digital logic circuit. The circuit given in the diagram consists of two logic gates. The first is a 3-input AND gate, which takes input A, B, and C. The output of this AND gate is then connected to a 3-input OR gate along with two other inputs D and E. Based on the diagram, we can express the final output F using Boolean logic as F equal to A dot B dot C plus D plus E. This means that the output will be high or 1 if either D or E is 1, or if A, B, and C are all 1 at the same time. Since our group number is 7, we converted it into a 5-bit binary number, which is 00111. This gives us A equal to 0, B equal to 0, C equal to 1, D equal to 1, and E equal to 1. We then substitute these values into our logic equations. F equal to 0.0.1 plus 1 plus 1 given equal to 1. So the final output F is 1. To verify this, we simulated the circuit using circuit verse. We built the exact structure using the AND and OR gates, set the inputs to 00111, and confirmed that the output F is high, which matched our manual calculations. First, we choose an AND gate with 3 inputs and an OR gate with 3 inputs. Then we connected inputs A, B, and C to the AND gate. And inputs D and E to the OR gate. Next, we connected the output of the AND gate to one of the inputs of the OR gate. After that, we assign the input values. A equal to 0, B equal to 0, C equal to 1, D equal to 1, and E equal to 1. Finally, the output of the circuit is 1. Because although the AND gate output is 0, the OR gate still receives 1 from inputs D and E. For task 2, we require to build the assigned gate, which AND gate for this group with the output F should connect it to a resistor and LED. The components we use are a power supply, 74HC08 IC, LED, switch, and resistors. First, we connected the power supply to the breadboard. Then we place the 74HC08 IC in the center of the breadboard, making sure each side is separated by the middle groove. Next, we added the switches, LED, and resistor. We connected the VCC power pin of the 74HC08 to the positive rail and the GND ground pin to the negative rail. We also link the power and ground rails across the breadboard to ensure consistent voltage throughout. The cathodes, which refer to the short leg of the LED, was connected to the negative rail, and the resistor was connected between the output pin of the 74HC08 and the anode long leg of the LED. We then connected the common pin of switch A to the input 1A of the 74HC08 and the common pin of switch B to the input 1B. Terminal 1 of both switches was connected to the positive rail, while terminal 2 of both switches was connected to the negative rail. Since we are using an AND gate, both switches must be turned on to provide a high signal to both inputs. Only when both inputs are high will the output go high, turning the LED on. If either switch is off, the output remains low and the LED stays off.
This simulation represents a circuit that combines AND gate and OR gate to control LED based on different switch inputs. The circuit is built on a breadboard. An LED is used as the output indicator connected with 1 kilo ohm resistor to protect it from too much current. Two logic IC are used, 74HC08 for AND gate and 74HC32 for OR gate. Both ICs are placed with their notches facing up to ensure correct pin placement. There are three push-button switches labeled as A, B, and C. Each switch has one side connected to ground. When any switch is pressed, it sends a signal to the circuit. The power supply connects to the breadboard to provide power to the IC. The wiring is set up so that switch A and B are connected to the inputs of AND gate. The output from AND gate is connected to one input of OR gate. Switch C is connected directly to the other input of OR gate. The output from the OR gate goes through the resistor to the LED. When the power is on, the LED lights up when both A and B are pressed together or when C is pressed. If none of the switches are pressed or only A or B is pressed alone, the LED stays off. The simulation tests all possible combinations of three switches. As shown in the truth table, the LED lights up only when both A and B press together or whenever C is pressed. This confirms that the combination of AND gate and OR gate works correctly to process the inputs and control the LED outputs. This simulation shows how to display the number 6 using a common cathode 7-segment display. The circuit uses a 9-volt battery to supply power. The positive terminal connects to the breadboard's positive rail and the negative terminal connects to the ground rail. A resistor is added to limit the current and protect the display from damage. The 7-segment display contains 7 LED labeled A to G. All cathodes inside the display are connected together and grounded. To turn on each segment, voltage is applied to its corresponding pin. To display the number 6, the segments A, C, D, E, F, and G are powered. These segments together form the shape of number 6 on the display. In this circuit, wires are connected from the positive rail to each of these segment pins, lighting them up.